Hi everyone, welcome back. Today we are going to discuss normality test, but in detail. That means we will take a look at the formulas. What are the formulas associated with normality test so that you can understand it better. And while we do so, since this is a little complicated, I have created a article for this. This is my personal article and on the blog. And if you want to understand it in detail, go through this article as well. So this in terms of step 1, step 2, step 3, everything I have given here, and the same we will discuss here as well today. So let's start with the first thing. What is the normality test, right? And a little fundamental about normality test. So let's start with the understanding, a high level understanding of normality test, right? So what is normality test? Suppose we have a data set and let's call this data set as a sample data set, right? Let's call this data set sample 1 represented by n number of samples, right? And this is our data set. And so let's take n equal to 100, right? We have 100 data sets, but these are coming from a sample population, maybe through a sample survey or something like that. However, this sample is coming from a larger data sets, very large data set, right? Let's assume this data set is about 10,000 minimum and assigned by capital N, right? However, we don't have access to this entire population data set. What we have access to is this tiny portion, which is 1/10 of the entire population with 100 data sets. Now, in Lean Six Sigma, as you might already know, that the one thing Lean Six Sigma fundamentally works on is a normal data set, right? And what is a normal data set? So if we plot the graph of the probability plots for a normal data set, it will go like this, right? Something like this for a normal data set, and this being the mean, which is denoted by mu, right? And we have this side 0.25, this side 0.25, right? And these are the rejection areas, right? Normally we call as, right, in terms of a normality test. However, what we try to get here, this is for a two-tailed, by the way, this is for two-tailed test, right? This and this are for two-tailed test. However, if it is for one tail we are talking about, so the rejection area will be 0.05. So this is not 25, this should be 0.025. This should be 0.025. And right, so our rejection area this. So what we essentially do is we identify something known as a p-value, and in Lean Six Sigma we find this value everywhere, right? And if the p-value is greater than 0.05, or if the p lies somewhere here, if p lies here, p lies here, greater than this region, right, after this point, then we say that since p-value is higher than 0.05, we can accept, or based on that we can reject the null hypothesis, whatever it is, whatever be the case, right? We'll see, we'll go to those cases. Now, however, if the data falls in this region, we say that the data follows the normal pattern, or the data follows a normality data set. What exactly it means is that the sample data comes from a population which is normal. In normality test, we have H0, which we can say as a null hypothesis, right? And HA as alternate hypothesis. These are the two hypotheses we need to prove or reject based on what the researcher or we want to do here, right? So the null hypothesis here is, and this essentially means that the sample data, which is N, is from a data set which is normal, or we can say is from a normal data set, right? And this we can say only when p-value is greater than 0.05. However, if it is not greater than 0.05, we can say that N is not from a data set which is normal. So that's very high level understanding of what is a normality test, what we do, and what are the hypotheses. However, what does exactly this mean then? So if we say we calculate a p-value, and based on the p-value we decide whether the data comes from a normal population data or it is not. But what exactly p-value is and where even we calculate p-value, right? So let's understand that first. So before getting into that, let me visually show you what it means, right? So for example, suppose we have this population which is 10,000 and we have a sample which is of 100, the earlier example which I shared. And if we go to here basic statistics and display descriptive, let's take both of them, and we will not see everything, only mean, standard deviation, and we will not see anything else. We'll see n total, right? So that's it. And graph not at this point, see that later maybe. I'll tell you where I want to do that later. So this is what it looks like, right? So we have a population data which is 10,000, and then we have a mean which is of 10. Both mean are little equal, you can say, based on the samples. The standard deviation is 1.9 and standard deviation 2.12. In a real world scenario, what will happen is you will not have the population data, right? Right. So in a real world scenario, you will not have this population data, right? You won't have this data. You only will have this data. This samples 100 and that's it. But based on this, you need to decide whether this data is coming from a population which is normal, right? This is what we have to prove. And for that we are calculating p-values. So let's take one by one and understand how do we calculate exactly. And let's go back to our formula first so that you understand what it is. And see, to calculate the normality or to calculate the p-value for a normality test, we need mean. Mean means it is simply x bar equal to summation 1 goes to 1 to n divided by n. So we essentially sum up everything and take the average, that's mean. Standard deviation, you know, that's the root of the squared deviation from the average. For simplicity of our understanding, we will try to understand Anderson-Darling AD test, right? For simplicity of our understanding, we will understand only AD test. And A square here measures the area between the fitted line, which is based on the chosen distribution, and the non-parametric step function. Now we'll see in a while what this means exactly and don't want to get into too much detail here. Then p-value, this is what we are talking about, and p-value is calculated based on A square, right? Based on the AD, and AD is calculated from mean and standard deviation, right? Along with mean and standard deviation. So let's try to understand, and again the p-value has dependencies, p-value is calculated based on the a square values, right? So whatever is ad star or ad dash, whatever you can say, based on that the p-value is calculated, and we'll see this in Excel and Minitab both so that you understand. So we have understood the formulas at high level now, and let's try to get into this test. However, before we go that, you must know that to have a normality test in Lean Six Sigma, there is a pathway, right? You just cannot go and start doing normality test for each and everything, all the data sets, right? We cannot do that. We don't need to do that, right? However, the first thing you must check is whether the data type, right? What is the data type? Like I was showing you earlier, the data type can be qualitative, quantitative, then under qualitative you can have nominal data, ordinal data, and discrete data and continuous data. However, normality test can only be done on continuous data. We cannot do this on any other sort of data. So what I have done is, if you click here, you will be able to download a data set which is a sample data set, and I'm going to show you that sample data set. This is the sample data set you can find there. So one is a sample data set, the sheet one, which is normality data. The next one is a normality solution data. Here I have done all the calculations in Excel so that you will understand how a p-value is exactly calculated. But before we do that, let's try to understand this and do it in Minitab and Excel both. So I'll just copy this data simply. This is 471 data, I believe, and I'll simply take this to Minitab. Okay, before that I wanted to show you something else. So let's go to graph and histogram with fit. Okay, and I want to see population and sample both, and I want to see this distribution. I don't want any bars or anything. Data display, we don't need anything, and multiple graphs overlay on the same graph. So we will try to see both data sets, right? Practical scenario, what will happen is, see, this is our population data, right? And you can see the sample data is so small versus the population data. And if I run this again only with the sample data, maybe you will be able to see it closely. So let me run it for you. Right. See, this is the sample data and only with 100 population. But when we see the population data against population, you can see this is very tiny. So even by seeing or by checking the numbers, it's very difficult to say whether this is coming from the same population or not. And that's what exactly we are trying to do. We will not have the population data always, right? We will always have the sample data. Checking the sample data, we can only say that whether it is coming from a population which is normal or not. So let's try to run this test in Minitab first, and I'm going to stat, and then I'm going to basic statistics, and if you go down here, normality test. So tolerance test of screws, we are taking this. You don't need to do anything else, and AD test is already selected here, and hit OK. So if you see here now, the p-value is 0.303, right? This is pretty easy, right? When you do it in Minitab, so this is very much easy to do. However, how Minitab has calculated p-value and what does it mean exactly? So if you do it in Excel, it's a bit of fun and you can understand what exactly you need to do, right? So to do this in Excel, let's go back to our sheet. This is our sheet which I have shared with you. The solution is here. You can see this, but I would recommend you start first with normality data and then do it yourself once you understand, so that you will understand in depth. And believe me, you will never forget the correlation between where a normality test is done and what we do exactly. So first, let's take the n, which is obviously we can just simply take a count here. So I've taken just a count of this, right? And this calculates all the quantitative values. That is 469. Then I can also do the mean and standard deviation, right? So here I can do, this is average, right? The standard deviation should be average. The mean should be average. I'm so sorry what I am saying. Then standard deviation. Here you have two options, standard deviation P and standard deviation S. But since this is not population data, I'll go with standard deviation S, which is the sample data. Finally, so these are our numbers, right? Mean. I'm not sure what color I have given. Let me take the same format here so that it is easy for you to relate it later, right? And I can do the same for the other column as well, right? So you can see now these are numbers. I'll take only for two decimals. This we don't need here, so this can be 0 decimal, right? We don't need, right? So once we have this, what we will do is we will first, with that also let me take you back to the formula as well, right? So this is our formula. We have calculated mean, we have calculated standard deviation. Now to calculate AD, what we need to do first is we need to calculate this portion, 2i minus 1, and then we will go into log of function of y. Y is the normality function, and we'll get into that. But first we have to find I. I is nothing but this one, right? Before we assign I to this, you just need to sort it from small to large, right? Go to data and then we do the sorting. So it is small to large. So we'll write here ith number maybe, and then we can just serial it, right? 1, 2. So this is our ith interval in the data, right? And I'll just drag it. You can double click it as well, right? So we have the ith interval now. Let me sort it out, right? So we have the second this thing now. So once we have the ith intervals calculated, come here and we will calculate fx. Fx is nothing but the normality, right? So this equal to normal distribution, and you can select x, which is this number, and then mean, and then we can, so I'm so sorry, this, yeah, mean, and then standard deviation this, and there are two things, cumulative distribution function and probability mass function. So select the cumulative distribution here, right, and true. So this is our first value of this, is the normal distribution value for the corresponding number. So we'll freeze all this 2 and leave it there and calculate this automatically. Now just to give you an understanding of what is cumulative distribution function and what is probability mass distribution function. So suppose you have a data set of 1, 2, 3, 4, 5, and this is a probability of 20, this is 20%, right? This is a probability of 10%. This is a probability, individual probability of maybe 30%. This is a probability of 25%, right? And this is a probability of whatever is the rest, that is 10%. So this individual probability, what we are seeing here, this is called the probability mass function, right? Now cumulative would be, so first one would be 20. So when we reach to second one, it would be 30%, right? And when reach to third one, it should be 65%. Next one is 90%, and finally 100, right? So cumulative distribution function is nothing but cumulative probability of the events together, right? So 1 to, then 1 to 3, 1 to 4 and 1 to 5, and these are happening sequentially, right, one after another, right? So that's how we can calculate the probability distribution for all this. So let's go back to our Excel sheet now. So we have calculated the probability cumulative function here, right, and these are all sorted, so accordingly our cumulative also falls in place. Now we'll calculate the inverse probability. Inverse probability is nothing but subtracting this number from 1, that is 1 minus this. I'm so sorry. Subtracting inverse probability is nothing but subtracting fx from 1, right? Enter. And then we will just select this, right? So we have now our inverse probability. However, this inverse probability is not sorted, right? So we'll sort this, sort inverse. I am writing here in this way so that you can understand it. To sort this one, what we have to do is equal to small, and array would be this is the data set, and k is the kth interval, or we can say the ith interval, right? And we need this one here, so the first smallest number here, but we need to freeze this, so freeze this accordingly. See, all these things are so complicated only because Minitab does it very simply for you. You may not have done it till now. So sorted inverse, right? And once we have this sorted inverse, we have more or less everything in place. Just so the next we have to calculate the s. S is nothing but this portion, right? Log of function y, you can call it x, function x, and log of 1 minus function n plus 1, which we already have calculated. So we just need to calculate the logs here. So we have everything calculated here now. We just need to calculate the s, or we can say that we need to calculate this portion. To calculate this, you simply come here to the formula again. You have to simply come here, equal to bracket start and 2 into I minus 1 again multiplied by log of fx bracket closed here plus log of inverse, right? So this we already have calculated, so we just need to add here and then multiply. So we got our, let's call it s, right? And what you need to do is, do we need to freeze anything? No, we don't need to freeze anything. So we'll just calculate everything till the bottom, right? Ignore this number, minus plus, doesn't matter. You can just use this formula, do it the same way I am doing, and you should get the result. Now what we will do is sum of s, right? So let me take this here. Sum of s should be equal to sum of so this is our sum here. Now from s we have to calculate AD, right? The next step is to calculate AD from this. To calculate AD, this equal to minus of C2, that is n, again minus, and you can take a bracket here, s divided by n again, right? We have that 0.432436, and what is this? This is this amount, minus n minus 1 by n. right? And multiplied by the other factors what we have calculated. So we have just done that. Now to calculate AD dash or AD star, whatever you want to call it, to calculate AD star, what we have to do is we have to follow this formula, right? A square into 1 plus 0.75 by n plus 2.25 by n square. And for simplicity, I am just going to copy this formula from here, which is already mentioned, and put it here. So we have 433131, which is the AD dash. Now finally we have to calculate p value. Now p value depends on AD, right? And since it depends on AD, we have different ways of calculating it. For example, if A dash square is between 13 and 0.6, then there is a formula, then there is another formula. If it is between 0.600 and 0.34, that is another formula. Similarly this. So for your use, what I am doing is I have all this formula written here so that you can use this sheet as a template. Just copy this formula and paste it here. All the formulas are available here. We'll just paste the formulas here, right? And P should be maximum of everything, right? Whatever we have to take the max of it, right? So this equal to max of this thing, right? So this is the p value we are talking about and which Minitab gave you. So let's now go back to Minitab and see whether this number matches, right? Right, so p value is 0.303 and AD is 0.42, which exactly we have here. Now if you go back and try to understand this better, what we did is we calculated the normal distribution, right? And if you again want to understand how did we calculate a normal distribution, it is a little complicated, but what we do is we find a relative probability for each of this, right? So that's how we calculate the fx and inverse of fx. Similarly, we calculate s, which is nothing but the total, and finally we are getting into p values, right? And so that's what we mean by exactly by normality test. Hope you would have understand, and if you have any doubts, anything, you can follow this page and share your doubts as well. Since this post is really long, I could not add it to the description in YouTube, so that's why I have created another sheet for all of you to understand in case you don't want to go through the video, and you can share your replies here. And thanks a lot. See you in the next video.